Here we have a problem on ratio. Okay, let's go to the question. If x to y equals to 3 to 4 and y to z equals to 3 to 4, then the value of x positive y positive z over 3z. Okay, let me take the given two ratios, that is x to y equals to 3 to 4, and the second ratio is y to z equals to 3 to 4. Okay, when I look at the two ratios, I find y in common in both the ratios, and the value which is corresponding to y in the first ratio is 4, and the value which is corresponding to y in the second ratio is 3. So, but we need we have to get the same value corresponding to y in both the ratios. But here we have different values corresponding to y. Okay, so for that, what we need to do is we have to get the least common multiple for these 4 and 3. So the least common multiple of 4 and 3 is 12. So we have to get 12 as the value corresponding to y in both the ratios. So if I want to make this 4 as 12, I have to multiply both the terms of this ratio by 3. So that when I multiply 4 by 3, it will become 12. In the second ratio over here, I have to multiply both the terms of the ratio by 4. So that when I multiply this 3 by 4, I'll be getting 12, the value which is corresponding to y over here. Okay, now what I'm going to do is I'm going to multiply both the terms of the ratio over here by 3. So 3 times 3 to 4 times 3. Then I'm getting x to y equals to 3 times 3 is 9 and 4 times 3 is 12. So now I got the first ratio x to y equals to 9 to 12. So here the value corresponding to y is 12. Okay, now let me go to the second ratio. In the second ratio, so both the terms here, I multiply both the terms here by 4. So I multiply the first term 3 by 4 and the second term 4 by 4. So y to z equals to 3 times 4 is 12 and 4 times 4 is 16. So I got the second ratio, that is y to z equals to 12 to 16. So here in the first ratio, the value corresponding to y is 12. In the second ratio, the value corresponding to y is 12. So we have the same value corresponding to y in both the ratios. Okay, now let's take the given expression. So because our aim is to find the value of this expression, that is x positive, y positive, z over 3z. Okay, since we got the same value corresponding to y in both the ratios, so here let's consider the value corresponding to x in the first ratio. That is 9. 9 is the value corresponding to x, the first ratio. So we can plug in 9 for x over here. And for y, we have the same value in both the ratios. So here 12 is the value corresponding to y in the first ratio. The second ratio also 12 is the value corresponding to y. So we can plug in 12 for y in this expression over here. And for z, we have 16 because in the second ratio, 16 is a value corresponding to z. So we can plug in 16 for this z over 3 times. Again, here we have z, so 3 times 16. So now when I add 9 and 12, I'm getting 21. 21 positive 16 will become 37. And here 3 times 16 is 48. So the value of the expression x positive y positive z over 3z is 37 over 48. I find this 37 or 48 in option D. So the correct answer choice for this one is option D.